Okay, let's look at a few now that are a little bit more interesting. These are, at a glance, not really just an exponential equation because there are multiple parts to them on either side there. However, if you look at all of the bases, you should notice that there is some kind of relationship between them all. So my bases on this one are 16, 64, and 1/64. So the relationship on those would be that I could write them all as either 4 to a power or 2 to a power. So this time I actually have choices. I think I'm going to go with 4 to a power because that'll make the numbers that I'm dealing with in the exponents a little bit smaller. So 16 is 4 squared. 64 is 4 to the third. And 1/64 would be 4 to the negative third. Remember, a negative power can turn a fraction into not a fraction anymore. Alrighty, so now I could simplify using my properties of exponents. So power to a power would give me 2x on that one. On this one, I'd have to distribute the 3 to the 3 minus 4x, so that would give me 9 minus 12x for the power. And on the right, I don't have anything to simplify there. Okay, now I don't yet have an exponential expression equals an exponential expression, so with the same bases. So I can't just set the powers equal to each other. I have to continue using my properties of exponents. On the left side of this equation, I have two exponential expressions with the same base, and they're being multiplied together. So when we're doing our properties of exponents, we learned that there was a rule that said that you could rewrite that, keeping the base the same and adding the exponents. Oh, I lost an x up here. There we go. So when I do that, then I could simplify that power. Let's see, 2x plus 9 minus 12x. That would be a negative 10x plus 9. And then at that point, I'm down to where I've got the same bases, so I can set the powers equal to each other. I know it's just a matter of solving this Algebra 1 type problem there. So I'm going to add 10x to both sides because I like for it to be positive, and I'm going to add 3 to both sides. And then I'll divide both sides by 10, which would give me 12 over 10, which I can reduce. That equal sign got a little weird. There we go. 12 over 10 reduced would be 6 over 5. Oh, this is another example where guess and test probably would not be a really good idea. You probably would not come up with 6 over 5 as an answer in any kind of succinct fashion. Alrighty, let's do one more like that. So this time, my bases are 3, 9, and 27. So the relationship between those would be they are all powers of 3. So that top one, the numerator there, is already just a 3, so I'm going to leave that one alone. 9 is 3 squared, so I'll rewrite that as 3 squared, and then I still have its x. And then 27 is 3 cubed, so that would be 3 to the third power, and then of course the 5x that was already there. Okay, so now I'm going to simplify each of those using my properties of exponents. 3 to the 2 to the x would be 3 to the 2 times x, so 3 to the 2x. And 3 to the 3 to the 5x, again, power to a power, so I'm going to multiply, so that would give me 15x. And, oops. That didn't come out right at all. Let me try that one again. This one over here is 3 to the x squared. There we go. Okay. Okay, so now I've got on the left side, I still don't have a single exponential expression, but I do have a quotient with the same base. So my properties of exponents says that I can turn that into a single exponential expression by subtracting those powers. So that would give me 3 to the x squared minus 2x. Finally, my bases match, so I can set my exponents equal to each other. So that would give me x squared minus 2x equals 15x. All right, so this time I ended up with a quadratic equation that I have to solve. And so I have to go back to everything we know about solving quadratics. Our first strategy is usually to create a 0 on one side and then try factoring. So let's try that. I'm going to make the 0 on the right-hand side of this by subtracting 15x from both sides. And then I can factor. Both of these terms have an x in common, greatest common factor, so I'm going to factor out an x. And then I can set each of those factors equal to 0 to solve. So that would give me x equals 0 when I set the first factor equal to 0, and x minus 17 equals 0 would give me 17. So this equation actually ended up with 2 correct answers, x equals 0 and x equals 17. And once again, you could check that by substituting both of those answers back in place of x in the original equation, and make sure that it makes the left side equal the right side. Okay, now you try the rest of the problems.